Here we're looking at section 3.5, and our big question for this section is how can you solve a nonlinear system of equations? We've dealt with a lot of linear systems. That's where we have two equations written in two variables. But now we're going to be looking at some nonlinear, so we're going to be including here some quadratics and actually some circles. So here's our learning targets. So we're going to be solving these systems of nonlinear equations, and then we're going to solve some quadratic equations by graphing, right? And remember that graphing is one of the ways that we can solve systems of equations. So here's where we're actually going to start. We're going to actually start by solving this by graphing. And there's many ways that you can do each one. It just depends on what you want to do and how comfortable you are. But you need to be able to use graphing and another method. So this I'm told to solve by graphing. So I just go in and I graph both of my equations, and I can use a graphing calculator or Desmos, either way. And remember that my solution to my system is where they intersect. So here I see these two equations, this quadratic and the line, intersect at the point 0, -1. So I want to just double check that it works. So I've got my 0, -1. That was my solution. So anywhere I see a y, I want to plug in a -1. And anywhere I see an x, I plug in a 0. So 0 times 0 is 0. -2 times 0 is 0. So -1 equals -1. So that one works. So we just have to double check it in the linear equation as well. 1 equals -2 times 0 minus 1. Well, that becomes 0. So -1 equals -1. So check. That does work, in fact. So that is my solution. Okay, so now we're going to be using substitution. Okay, so the first thing I want to do is I want to get one equation written in one variable. So I'm going to solve for y in this second equation. And I just use the second equation because it's a little bit easier. Okay, so I solve for y there. So y equals -x plus 4 because I just subtract x from both sides. So now anywhere in this top equation where I see a y, I plug that information in. Okay, so now I have x squared plus x minus, and then a negative x plus 4. I always want to keep that in parentheses. So now I can simplify. I can distribute this negative sign, I can combine like terms, and I can simplify. Well, then I see I just have a quadratic, so I want to write it in standard form. I get everything over to one side of my equation, set it equal to 0, and then I solve that quadratic. Here I see that this one's easily factorable, so I factor this quadratic and I end up with my two solutions. So x equals -3 or x equals 1. So now that I have those two solutions, I try and I substitute them back into my equation. Okay, because I have to be able to get my y. So I first substitute this -3 in for my x, and then I substitute in my 1 for my x. And I end up with my two solutions. So my solutions are -3, 7 and 1, 3. And I can always check these solutions by graphing. Right? And the reason I can have two solutions when I have a quadratic is because remember a quadratic is a parabola, and that line can cross the parabola in more than one spot. It can happen in two places, so it is possible for two solutions. So here we're going to use elimination. Okay? So we've used substitution, now we're going to use elimination. So I would like to use elimination here because I see I have a -y and a positive y, and I know that if I add these two equations together, that will cancel out. So that's exactly what I do. I add my two equations, since these two will cancel out, and I end up with 3x squared minus 3x equals -2. So again, I just have a quadratic, so I want to write it in standard form, get everything to one side. If I don't want to factor that, I can use the quadratic formula, which is what I do here. So I generally don't like factoring anything with a value greater than 1 in front of my x squared term. It just makes it funky. So we're going to use the quadratic formula. Well, here I notice, right, I have a negative value inside my radical sign, or that's my discriminant. Okay, so since my discriminant is negative, I have no real solutions. And that can also happen with a quadratic, because if my quadratic is here and my line is down here, they never touch, so they would have no solutions. Okay, and I know that just because I will end up with an imaginary number here. Okay, so now here's a couple that I want you to try. You can either graph them, but then you either need to know substitution or elimination, either one. So make sure that you can solve these using those as well. Okay, so now here I told you we were going to be dealing with circles, and I know that this is going to be a circle because I have an x squared and a y squared, right? That's the equation, the general equation of a circle. So I'm going to use substitution here. Well, my second equation is already solved in terms of y, which makes it very nice and easy. So I can just plug in everything here wherever I see a y in the first equation. Okay, so here I have this negative 3x plus 10 squared. That does not mean I can take this first term and square it and the second term and square it. What I have is I have a negative 3x plus 10 times a negative 3x plus 10. I cannot forget that. I can't just distribute that. So that's where we're getting these values from. Okay, so I expand this out. So now I have x squared plus 9x squared minus 60x plus 100 equals 10. Well, now I'm left with a quadratic, so I combine my terms and I write this in standard form with everything over on the left side. I see I can divide everything by 10 to simplify it. Now I see that this can probably be factored, so I go ahead and I factor this one. It also creates a perfect square trinomial, because I would end up with x minus 3 times x minus 3, and since those are the same thing, it's a perfect square trinomial. So I can use my zero product property and solve for the x equals 3. Okay, so now I have to find the y part. So I take this and I plug it back into my original equation. I would use equation 2 just because it's easier, and then I can just double check my solution. And you'll see here that I have the circle and the line, and they do connect in one place. So I know I was right. So here are several more systems for you to try. Again, these ones are with circles. Definitely try this number 6 here with fractions, because you're going to be dealing with some fractions as well. Okay. So sometimes we're going to be given one very long equation, and I can use that to graph as well. So actually let's take a look at what this actually looks like. So here we go. So solve for part A here. 3x squared plus 5x minus 1 equals x squared plus 2x plus 1. So that seems like two very long things. So I want to solve this by graphing. So to do that, I can set each piece equal to y. So I can have y equals this and y equals this. Well, so now that's just a system, and I can graph that. Okay, so there's my original equation. I take each side of the equation and make it its own equation, and then I can just graph it. I can graph it using Desmos or my graphing calculator, either way. The cool thing is when I'm using a calculator, I can use the intersect feature. If I'm using Desmos, we saw here, I can just click on the point where I think they intersect, and it will actually tell me where they intersect. Okay, so that will tell me the x value and the y value of each of those. Okay, so now let's look at part B. So again, I see I have a very long equation, a bunch of stuff on the left side, and a bunch of stuff on the right. Well, I'm going to set this up as two equations, so y equals and y equals. Now that I have those two y equals, it's just a system, so I can plug that into my calculator and I can solve. Here, we didn't have the picture here, but we would see that we can use the intersect feature, or we can click on it in Desmos and see that when x equals 0 is where my solution is. So here I want you to try these ones, and I would definitely use Desmos for these. You can use Graphing Calculator if you have it. Either one will work. So now let's look back at our learning targets. So first we solved some systems of nonlinear equations, and remember the ways that we could do this. We could graph them, we could use substitution, and we could use elimination. It's really important that you know either one of these two. Be able to be comfortable with them, because we can always have a graph, but sometimes you will need to do this by hand, so you need to know either substitution or elimination. So make sure that you have one of those two down super solid. And then our second learning target was solving quadratic equations by graphing, and that's where we just have a quadratic on one side of the equal sign and a quadratic on the other side. Then we set them equal to their own equations and graph them that way. So now that we've gone through our learning targets for today, go ahead and work on your homework for this section.